Okay, we have to be really careful for some of the layer when we do spatial drawing, because that's how I cannot guarantee, but I maybe I was sleepy. Anyway, facility location. We're going to do facility location. Okay, now I'm back and I'm an adjective. Okay, suppose that we are an analyst for an organization that owns several facilities in a city, and we are asked to find the best location for new facilities. The classic problem of this kind is to locate facilities for a chain of retail store in an urban area, but other examples are federally qualified health centers. As studied in here and the public swimming pools earlier here in the most general case, we will the organization has existing facilities that will remain open, a set of competitor facilities, and a set of potential new locations from which we want to determine the best subset of a specified size. Another case is where a subset of existing facilities must be closed, as with the Pittsburgh swimming pools, for which we want to determine the approximately 16 of 23 facilities to close. Yet another case is where there are no existing facilities and we want to locate to new facility. Alright, ArcGIS Pro location a location model. Location a location model. In the network analysis collection of model handles these sort of facility location problems. So inputs are a network dataset, locations of facility types, existing competitors, and new potential sites. So demand points and a gravity model. Demand is represented by polygon, centroids, blocks, block groups, tracks, zip codes, and so on, for which we have data on the target population, generally from the U.S. Census Bureau, such as youth population. Resistance to flow in the network, called impedance, is represented by a gravity model and can be distance or time traveled along shortest path to facilities. Several optimization models are available within the location model. We will use the maximize attendance model, which includes a gravity model for which we apply parameter values, and a network optimism model that select a specified number of new facilities locations that maximize attendance. So here we will run a model to choose the best 16 out of 23 swimming pool to keep open using geographic access distance from the nearest pool as criteria. Of course, we open our 9.4 project, so we will use the Pittsburgh mark. Bookmark again, they really like to use bookmark. I don't, but I have to learn and use it. So this map has the 32 pools, block, centroids with youth population and Pittsburgh Street network dataset also included in the Pittsburgh street central line layer symbolized using a 10 color for visualization. So note that the Pittsburgh block centroids table has an attribute cutoff minutes, which has value 10, meaning that any block centroid farther than 10 minutes travel time to the nearest pool under consideration will not be served, and therefore has none of its youth going to a pool. We will calibrate the location allocation model. So the location allocation model is straightforward to use, but first we must fit a gravity model to the 5 points of the scatter plot at the end of the that's what we did in previous video. In other words, so the previous videos that produces data points, but the location allocation model needs a gravity model function fed to those points as input. So available in the location allocation model are three functional forms for a gravity model: linear, exponential, and power. The power forms does not work well for classes. For classes with short travel time, such as for the swimming pools, a few minutes, so it is not discussed further here. The linear form is easy to understand and use. It's based on an impedance. So impedance cutoff 10 minutes for the swimming pools. So it estimates that 100% of the target population that gives at pool uses for of course, no one lives at a pool, but some are nearby, and nearly 100% of the population uses the pool. 75% uses the pool at a quarter of the cutoff, 2.5 minutes. 50% at half the cutoff time, 5 minutes. 25% use it at 3/4 of the cutoff, 7.5 minutes, and 0% of the cutoff or beyond, 10 minutes or higher. If C cutoff in minutes and T impedance in minutes, and then as a percentage, use rate 100 times 1 parenthesis 1 minus T divided by C. For T ranges between 0 and C and is 0 otherwise. Exponential is the most applicable gravity model for the swimming pool case, because it declines rapidly as travel time increases and generates two other cases very well. The Microsoft worksheet exponential XLXX available here provide a method of fitting the exponential model to the result here. So we will open, let's go back here. We will go back to chapter 9, go to data and exponential. We'll open this beta, which currently has the value of 0.25. So it's the one parameter that we must choose, optimize in the worksheet, and provide in location model. So location model, impedances or average travel time in minutes in gravity model. Use rate column has the estimates 9 to 3 for its multi-tiering. Service areas expressed here as fractions instead of percentages. Cost is an exponential function. Beta t to the beta and teeth exponential used in the network optimization model to represent system impedance, and the model uses pro-use rate as the gravity model. So the task here is to vary beta until we get a good feed of the pro-use rate to the gravity model use rate. Average absolute error is a guide for choosing beta. We must minimize it by trial and error. So now we will enter the following beta value at a time into the worksheet. So we will put right here, so that we have 0.10, 0.15, 0.20, 0.25, 0.30, 0.35, and no resulting average absolute error values. So next are the results, which are also saved in the worksheet here in row 13 through 19. 13 is right here and 19 is right here. So beta equals 0.25 is the best fit out of the value trialed. Note that if we are comfortable with Microsoft Excel, we can easily modify this worksheet for other case study or project by adding, copying rows, and changing impedances. So now we will close it out. We don't have to do anything. We just look at it. Okay, we don't have to save it, okay? And configure and run the location allocation model. So on the analysis toolbar, so I'm gonna minimize this because we still need this window. Okay, so in analysis, and we will go to network, okay, network, and then we will go to location allocation. And it creates a location allocation group layer in contents pane. You just wait a little bit, wait for it, click the network contents contextual tab, which is right here. And then the horizontal toolbar for this model open. If the toolbar never closes, we will want to reopen it. And click the location allocation group layer in the contents pane. So right here, location allocation is right here. And in the import data group, we will click import. Right here, we will click import facilities. So, okay. And make the following selection. Of course, we will do it. And then when we finish, we will close it out. So this tool can be run more than once to load different kinds of facilities. And notice that the default facility type under field map property is candidate. Candidate. And then, so right here, it doesn't show anything yet. But we should have a candidate, and which is correct for this model to run. Other values are required, competitor, and choose. So now we will, a location, we will do facility, import, we will say pools. And facility type, candidate, yep. And we don't have to do anything, 5,000, snap, okay, instead of this one, 5 meters, click run. So, and then we will import demand points and make the following selections. Under field mapping property for weight, we will select import demand points. So we have to go to import demand points. So click import demand points right here. Okay, and then we will click this layer property. And make selection. Okay, so add locations. Add locations. Add a location. Import demand points right here. Okay, so now add a location and demand points and input location. It will be Pittsburgh Brock, Centroid, field will be weight, and age, type 15, yes, geometry, that's fine. And default value is 1, and we don't want this. We want to snap to append existing location. No, snap to network. Okay, so that we did was we click right here, import demand points, and make the following selection. Of course, under field mapping, we did property. Here we chose weight, and we select age 5 to 17, and default value is 1. And this is the target population for the cutoff minutes property. We select cutoff minutes field. Cutoff minutes field. Okay. Alright, I think weight. Do we have to choose another one? For the cutoff minutes property. We need to do weight and then cutoff. Control there. So weight. We cannot choose at the same time, so we have to wait and see how many points it load. It should be 7,493 total. And in the travel setting group, then we will do something later, but we have to wait a little bit and see what's going on. And because they asked us to choose the cutoff minutes, select this. It's not totally there. Okay, so let's open attribute table. It should be 7,000. 7,000. Yeah, 7,493. So I'm gonna close it out. There. And then we will have in the travel setting group,